Welcome to a new test and teardown video. Yes, another oscilloscope. How do you like that one? I just came home from another flea market and I just had to have this cool old Russian oscilloscope. I mean, that is just a what the heck is this? I can't figure out exactly what is everything here is doing. That's probably on off, right? And that gotta be the input. So here's what I did. I took some pictures of the front like this, and then I used a translator and tried to put in the pictures, and then it adds on top of that, it adds the Russian to English translations on everything like that. So I got an idea about what is doing what. I also find some text on the top. See, there's also a label here on the top, and that one definitely also need a little bit of a translation. And here on the side, let me try and there's also a label here. The fun thing is when I translate this one, it just say label 50 megahertz. So whatever that is. Let's look at the back. So here's the back of the unit. It even says 1978. How cool is that? And that is, what is that? Again, it's the same, maybe label something. Is this input, output, whatever is that? That is obviously a fuse. No, this is voltage selection, right? So how is this? How do you do that? And here's an adjustment for some 12 volts. And by the way, this thing is insanely heavy. I just had it on my scale and it's 8.2 kilos. Really heavy duty. So I feel that I need to open it and inspect it before I power it up. Yes, I am a chicken. I don't want to blow this up. I really want to inspect it a little bit first. But oh yeah, I want to show you this. Before we proceed, you're gonna love this. Look at that one. So here is, look what happens. So there's a dial that rotates around the screen. What? That gotta be the sweep speed, because it says something here about megahertz, right? So that's like megahertz and something, right? And here we got milliseconds. So what kind of I don't know exactly what is going on here. Here we got some dB. So this is attenuation. It's all a little bit weird. And this also looks like an attenuator for input, right? But why would the dB and all the megahertz and I mean, is this a spectrum analyzer or is this an oscilloscope? And look at the frequency ranges, 0.4 to this, and then it goes to this. Is this a frequency range? Is that even possible? That cannot be possible. And then, this is probably the input for the high frequency stuff. I don't believe this. We gotta investigate a little bit more. This is going to be super interesting. You are not going to believe what I'm finding here. I mean, this is an old transistor thing from 1978, and of course that will be brightness and focus properly, right? So of course that is high voltage, and they carefully marked that and even protected that, so that's all good. And then we got a, can we lift this? So there's a, I'll probably have to, see, it's hinged. See, that is nice. So I just unscrew this and then we can flip up. Well, look in here, there's a huge mechanical filter tuning oscillator mixer kind of thingy here in the middle, and there's this is coupling. There's actually also an RF switch, and look at that. So here's the dial for the frequency stuff, and that rotates also the screen indicator like that. And then here, this one flips. This is a rotary switch that is doing something with the in-out kind of the signals, and then we got 4 different coax cables that goes to all sorts of stuff. And there's a pulley system that goes all the way around and whatnot. It's actually quite beautiful and compact design. See, there's a bulb down there, and this shines light to a little that one probably, so that shows it's powered on. Oh, so there's like a huge metal thing, and then there's a quite big mains transformer right here, high voltage capacitors, high voltage diodes. So that's of course for the CRT. The CRT is hidden inside a very big, stable, thick metal shielding. Oh, look how compact it is. And full of connectors and cables and stuff like that. So here's also a little PCB that's doing some stuff. Hey, we got a little IC here. You can probably take out all the different modules. Somehow that's of course the power supply, and you're not supposed to touch any of that. Okay, got it. Look at the transistors. Oh man, this is definitely a lot of entertainment in one box. And the other side here is also full of electronics. This is just low-tech analog stuff. See, this is probably some transistors. Yeah, all that will be transistors. That looks a little bit like deflection amplifiers, if I'm not wrong. Here we got power components. Oh yeah, see? If I remove this, then I can hinge those two out, and then we can have a look. Here we go. Yeah, I think we can see some more in the bottom here. Oh yeah, here we can see the big, beefy transformer, and that is what I think is transistors, or what is that? They are looking really funny. Wow, I didn't know that this unit would be so cool. Some more funky stuff. This is just like going to another planet. Everything here is definitely special. That is probably a field effect transistor or some sexy stuff for the input, because it's, yeah, that's probably in scope mode input. That is at least what I think. I really hope this is also a scope, but it's definitely also some kind of funky stuff as well. Wow, man. How about we power it up and see what kind of kaboom there is hidden inside. I just can't wait to look at those boards. Oh! Did you hear that? Power is out. Yeah. I took the power. Kaboom. Okay, that was a bad idea. Man, so there was a kaboom in this one. Oops. Yeah, that's typical. We are now outside, and that is for a reason. And there's a very, very bad smell inside this unit. And not only did I take the entire house power supply, because there was a spark over or blow over to chassis, and of course I have a ground protection on the chassis because I don't want to murder myself. So where the heck is the smell coming from? That's what I need to figure out now. My goodness, this is compact and crazy product. Look at that. Oops, is it that? No, it is not. But there was a very clear kaboom. Oh, look at those transistors and all that. That is just beautiful. Yeah, those are transistors as well. Oh, nice. Now it started to rain, so damn it, man, I need to be inside again. So that smell is in here somewhere. I just haven't figured it out yet where that is coming from. But meanwhile, I'm just inspecting all the different circuit boards. And those are really quite cute components. They're mounted like upside down. Like that. And then we see some more of this big funky filter, resonator, oscillator thingy, whatever that is. And we got another box for high frequency stuff down there, right? Oh man, this is interesting. So, so this is my input power. And here is, look at that. Here's an input filter, and then there's another, then it goes around to all sorts of stuff. So where's my leak to chassis? But there's a smell in this area here. Oh, by the way, the fuse isn't even blown, and there's a funny thing about how this fuse is. You push it and rotate it. So you need to be careful about voltage selection and fuse change. But as long as the fuse is not blown, I mean, it can't be that. So if you look at the previous clip with the little problem, I believe that I tested it in off. So this is mains power on and off. Right? And remember, we had a spark and it took my protection relay immediately when I applied mains to the input, and I had a protective ground on the chassis. Always do this, guys. This will save your life, because what happened in this case is that there is something wrong with the mains entry filter, and there is a leak to chassis here in that filter. So if you don't have this ground, the unit's probably gonna run, and there's something on the display, and when you poke around with all the different plastic knobs, you don't even realize this. First time you touch some metal here, you're going to get an electric shock, or even worse, I don't know if that is even worse, but you could potentially connect this to some of your much more nice and new and expensive equipment and blow something up. So that is why I always have my ground wire and stuff. So yeah, I'm trying to dig out this mains entry filter here. And see, screwed in here, so I had to remove this extra beautiful add-on rear plate. I don't know. Yeah, okay, you need that to hide away that hole. Okay, that's the rear of the CRT. Trying to get this bugger out here. And I removed the two screws, and now it turns out that this filter is not only the filter, but it's also the holding assembly for two rectifier diodes that obviously goes to ground or something like that. Are they isolated? No, and I don't really see they are, right? Maybe this piece of metal here is isolated. I mean, what is the idea here? So that is my mains entry super duper thin wires, and they are sewed together with some other wires that goes like here, right? And then those two diodes there are connected together like that. So what is this doing? Funny, I don't see any smell marking thingy, but yes, here is my kaboom. So it went that fast, it melted this coil. So there's a short somewhere else. Oh yes, you see? Isolated from this chassis it is. Yeah. So two diodes, that is just whatever they are, mounted like that. This is a little bit weird. I don't understand that. And only two wires. And then see, one of the wires is same thickness as the other one and also wide. That is definitely a way to make an accident. So why is it like that? So let's see, where is this isolation problem. So I'm gonna take my good old Meggy Mega here. So we got two different parts in this, one good and one bad. So let's try and measure the good one first. See? Nothing. Let's try the bad one. Ooh! So look at that! Ha ha ha. So there's a high voltage short leakage problem with that capacitor here. That is causing all the problems. What I could do also, I have now measured my input here. Let me have a look. Let me show you. So here's those two are still carefully marked. That's my mains entry. Those two wires goes to the two diodes that I do not understand, because they kind of point each their way. So what the heck is the problem with that? But what I've done is I took my ohm meter and measured between these, and they're completely open and there's nothing to chassis. And when I flip the on-off switch, I get 30 ohms between those. So that means I didn't blow the fuse, I didn't anything bad, right? So what we can do is we can take these two and measure if we got 1000 volt isolation to chassis, and that means I should be fairly safe to continue powering this unit up and not causing any more problems today. Now here's what I've done. I leave the instrument in power on, so that means there will be a short, like about 30 ohms DC between those two. And here I go with my maker again. I don't know if this is easy to see, but I'm of course measuring on mains entry to chassis. You see, there's nothing. And I can of course take the other one if you don't believe me. You see, there's nothing. And of course I can just take these two and prove that they're of course, see, they're shorted. That's because this is directly into the transformer, right? So, happy me, we can continue with this funny thing. It was actually inside that filter through capacitor here. The explosion actually went all the way through here, so there's a burning hole in here. and it cracked it as well here. Oh, that is something. And that is the other one that's actually still okay, but I prefer to change both of them. So here we got two new ones. Oops. And they of course fit in the holes, because that is more or less a standard thread for stuff like that. So I can put in two new ones. Oopsie doopsie here. And then everything here is gonna be nicely restored back to working order. I even got the value for the inductor here. I believe that is 125 micro, and that means amps 0.4. 5%, and look at that. You even get, this is from 1977. Yeah. So I am feeling lucky. So here's what we're gonna do. We're gonna try again. So we're gonna turn off the light, and let's turn off everything else, because maybe the power is gonna go again. I don't know. That is what can happen. It is in here, and I am now a little bit more careful. So I'm gonna crank up the voltage slowly. So that means I'm gonna turn on this instrument. I think that I've left everything here in the middle. So hopefully we're gonna see a picture. Then I'm gonna turn on here, and then I'm gonna dial up the voltage slowly. And I don't see any kinds of stuff that worries me. There's 100 volt, 11 watts. We can easily continue all the way to 200. And so that is 200, and oh, look, we got something. How does this work? Oh, man. That is the brightness. It is way too bright. It's a little bit weird the way that I think I am in scope mode, probably because I am over here, right? What are we doing? What are we looking at here? Okay, there was a funny response with that one. And here, what are we doing with that one? So it's using about 30 watts at the moment. And what is this? This is the bandwidth. Maybe this is the switch to make it into scope mode. I actually don't know anything about this. So how do we? What are we doing wrong here? Aha! That is spectrum analyzer mode, right? And that should change something here. Yes, it does. Well, what is that then? So that is the bandwidth. Yeah. Let's give me some. And then, yeah. So that is 400. No. Hang on, let's try and give it some signals. It is actually working. Wow, man, this is really funny. I don't know if you can see this. Let me dim the light a little bit here. It is really funny, this picture, what we're seeing here. So I am now in 0.4 to 235 megahertz. And then I dial this one. See what happens here? And then this scale out here is that scale that matches this range. So look at that. I go to the 100, soups, and here is this funky pulse. I just put in 100 megahertz. It is of course really critical here. I need to be very careful about what I'm doing. So now I've adjusted it to about 100. So let me go to my signal generator. No. Why is this not working? That is weird. If I turn off my signal generator, the signal is here. I don't kind of get it. I thought that was my signal. So why is it working like that? So it's something to do with that. So is this a marker of some? And it's also here. I don't know. I'm not super convinced. Maybe it has something to do with sensitivity. So here we go. My signal is definitely affecting that readout, right? And here is something to do with bandwidth. So how that? Okay, so that. I don't know, man. Maybe I'm too stupid to figure this out. But here there's definitely a, see, definitely something happened. So this is my signal, and then what? It's just all over the place. It's not a spectrum scope in that way that we normally understand it, but it does definitely sweep, span, search for something. I don't know. So this is in the 0. So let's go for 50 here. So that's still, and that's also my signal. This is probably the weirdest, funkiest scope. I don't know yet what to say. I don't know. It's at least it's not blowing up anymore. Oh man, I need to play a little bit more with this and figure out how to make it into the scope mode. So that was also, this is the analyzer mode like that. And I think you can also see, look at that. It's probably also analyzing impedances or some other funky stuff. You can probably do a lot of cool things. And then you go into oscilloscope mode. And then it's not. No, yes, look at that. Now it's also responding to my frequency, my input. So let's try and give it 1 megahertz. No. So is it still responding to this? Okay, so let's give it 50 megahertz. No. It's because I am in. So why did it respond to my 100 megahertz? That is something that it responds to. Ooh, it is absolutely crazy about 100 megahertz. And if I go to 101, I see nothing. Really? So that is my bandwidth or something like that. Okay. I just totally don't get what the heck it is we're seeing here. And I mean, I've actually been playing around with quite a lot of scopes, but this one is just not giving me any kind of what the heck it is. It's, what are we looking at here? It is responding to this, and it's just super crazy about 100 megahertz. Oh man, let's try and put in something in here, right? Okay, now we are in oscilloscope mode, and that one, it actually says milliseconds here, so this is the time base. And there's actually only 3 ranges, but they overlap a million gazillion times here by this variable. See, this goes from absolutely crazy to, that's just way too aggressive, but that is just the way it works. So we got, see, again, it goes all the way to, see, insane overlap in the settings here for sweep. And it's one of those where we have to adjust here to see what it is you see, and then you can also adjust some synchronization here, and then well, I mean, it is working and it can measure frequencies, the spectrum, the detection, funky shit here, and this is absolutely weirdest multi-funky scope. I'm actually quite happy that I managed to get it up and running without blowing up or anything, and that is my level. It's almost working. Yeah. One more funky things for my collection. Oh man, this is the weirdest. It's just like one of those IQ tests where you have to figure out how to get this damn thing to work. You know, where everything is just not easy. Yes.